Hi, in this video we're going to look at Unicode. If we look at strings, we really have to understand what Unicode is. So a little bit of history. In the beginning there was something called ASCII, the American Standard Code for Information Exchange. And it addressed the problem of a standard for assigning numeric codes to characters. And these were printable and non-printable characters, and they were used by teletype machines. And so we wanted these numeric codes, and also we wanted a method to encode the value into a binary format, and it was done using sequences of 7 bits. So given a data stream filled with zeros and ones, right, that's all really that computers understand, zeros and ones. So that's how we can transmit information. We have a data stream with zeros and ones. Well, we needed to chunk it up in order to determine which bits were a character. So by using the 7-bit sequence, we just counted up in 7 bits, and then we could decode the character. We could take those bits, which is just a binary number, and then convert that into the equivalent character code. And then the font handled displaying the character, and for displaying the character, it's just really a bunch of pixels that you have on the screen or on a paper if it gets printed or whatever. And that's called a glyph. So the supported character set was limited. It was only 128 characters, 95 of which were printable characters, like A through Z, capital A through Z, the digits 0 through 9, and then characters like, commas and periods and exclamation points, division, etc. And then we had 33 non-printable characters, things like control codes, for example, new lines, tabs, and more. So here's a sample of the ASCII table. I didn't have space to put all of it here, but you can see that here we have, for example, the character encoding for the capital letter A. It is the decimal 65, or in hex, it's 41, right? The character code for, let's say, lowercase a was 97, or 61 in hex. But you'll notice that we also have these non-printable codes that come in the beginning, things like start of heading, acknowledge, line feed, form feed, all these kinds of weird things. And that was because they were used for teletype machines. So these were characters that were non-printable characters, but they essentially caused something to happen on the teletype machine. So that was defined in the ASCII standard. Now attempts were made to extend the ASCII set, and it was still far too limited. As you can imagine, the ASCII set containing 128 characters, well, there was no room for defining standards for letters from other languages that use an alphabet that wasn't the Latin alphabet, right? The A through Z and capital A through Z that we know and understand. And the standard was poorly followed. People would implement their own little versions, and so there was a big problem. And so Unicode was born, and it was focused on assigning a code to a character, and that's called a code point. And that does not specify how to encode the code points into a binary format. Remember that ASCII had both. ASCII was defining a code for a character and the encoding format, saying you will use 7 bits and then you break this up into 7 bits in your data stream. Unicode doesn't do that. Unicode is really just assigning a code to a character. There were other standards that happened for encoding those code points into a binary format. You had one called UTF-8, and that's a very popular one, and that's the default in Python. You also have other ones like UTF-16, UTF-32. And basically, it's really just how do you take the sequence of characters, right? You can translate them into code points, which are basically values, numerical values, but how do you encode them into a data stream of zeros and ones? So we're not going to be concerned about the details of how that works. It's actually quite straightforward, but we don't really need to understand that. We just need to understand that Unicode is one thing, and then the encoding, UTF-8, UTF-16, and so on, is something else. 2 different things. And UTF, by the way, stands for Unicode Transformation Format. And at this point in Unicode, there's well over 100,000 characters or code points defined so far. So that's way, way more than the 128 or 90 odd printable characters that ASCII had. So let's look at code points. Well, first of all, they were made to be backward compatible with ASCII. ASCII is so prevalent, even today, that it needed to be compatible. So the ASCII character code for A, as we saw in the table, for example, was 65 in decimal and 41 in hexadecimal. The Unicode code point for A is also 65 in decimal. So we have that compatibility that the numeric code assigned to the characters that were in the ASCII table are the same in the Unicode. So decimal is base 10, which means you use digits 0 through 9. Hexadecimal is base 16, which means that you have 0 through 9, and then you have A through F. So what is hex? Let's take a look at it very quickly. And basically it's all about numeric bases. And if you don't understand numeric bases, I'll give you a kind of a quick overview of what they are, but you may want to go and study that up on your own somewhere. It's got nothing to do with Python specifically, that's just a mathematical thing. So decimal system uses powers of 10. So we have 10 digits, 0 through 9. So if we look at the number 9034, then we can think of it as each slot basically representing powers of 10. And so starting from the right, we have 10 to the power of 0. And of course, any non-zero number to the power of 0 is 1, right? So 10 to the 0 is 1. So this box here represents the 1s. This box here is 10 to the 1. It represents the 10s. Here, this box here is 10 to the 2, represents the hundreds, and this one is 10 to the 3, represents the thousands, and you would keep working your way. So if we have 9034, then starting from the right-hand side, we have 4 times 10 to the 0, which is going to be 4, plus 3 times 10, which is 30, plus 0 times 100, plus 9 times 1,000. So that's 9034. That's how our decimal system works, and we kind of are so used to it that we don't think about the fact that it's really broken down this way. So binary uses powers of 2. So we have only 2 digits, 0 and 1. So those slots now that we have are powers of 2. 2 to the 0, which is 1. 2 to the 1, 2. 2 to the 2, which is 4. And 2 to the 3, which is 8. So the binary number 1011 turns out to be 1 times 2 to the 0 plus 1 times 2 to the 1 plus 0 times 2 squared plus 1 times 2 cubed. And so that gives us 11 in base 10. So 1011 in base 2 means 11 in base 10. Well, hexadecimal uses powers of 16. It's base 16. And so it has 16 digits, 0 through 9 and A through F. And here, A is 10, B is 11, C is 12, and so on, and F is 15 in decimal. So the hex digit A means 10 in decimal. The hex digit F means 15 in decimal. And so if we look at the boxes again, we have powers of 16 now. 16 to the 0, 16 1, 16 squared, 16 cubed. And so if we look at this hex number, FC15, now remember that F and C are now valid digits in hexadecimal. So if we do that, then we have 5 times 16 to the 0, being of course 5 times 1, plus 1 times 16, plus C, well, C is 12, so 12 times 16 squared, plus F, and F is 15, so 15 times 16 cubed. And so we end up with this number here, 64533 in base 10. So the hex number FC15 is the decimal number 64533. So that's the difference in all those numbering systems. Now, why do I bring up hex? Well, hex is used fairly often in programming, and most of the Unicode tables that you'll find out there are going to give you the numeric code for characters, the code that was assigned to the character, like we saw for A. It will give it to you in hex, not in decimal. So let's take a look at the Unicode Character A, and you can follow this link, which I'll have in the Jupyter Notebook that's downloadable. So if we look at that page, we'll see that we have basically this Unicode Character A. It has a code, 41, and that's the hex code. Then we have the character name, and this name is a standard as well. So it's Latin capital letter A. That's important to remember that that is the character name and that is a standard. And then we have things like, for example, the lowercase version of this glyph, essentially. And if you're looking at the lowercase, it will give you the uppercase character. So you have these relationships between letters, and there's a lot more going on as well. For example, it tells us that the category is an uppercase letter. The script is Latin script, and so on. So we have various categorizations. So the odd function in Python returns the code point for a single character, and it will return it in decimal. So if we look at odd of the character A, it will tell us 65, which was the decimal character code, both in ASCII and Unicode, for A. To get the hex number out of a decimal number, we just use the hex function, and it will convert that decimal number to a hex string. Obviously, it's going to need to be a string because we're using digits like A, B, C, D, E, F. So that's going to have to come into a string. So if we do hex of 65, then we'll get this string, 0x41. So the 0x is really just a prefix in the string that indicates that the digits following this 0x prefix is in hexadecimal. So let's take a look now at this character, for example. So if you go to that link, which will be in the Jupyter Notebook as well, well, that's the Unicode character alpha. So that's for the glyph alpha. You'll see that the name of it is Greek small letter alpha, and there's, of course, all the other information as well. And this is the character code for it, 3B1. That's the hex code for it. So we can look at, if we just take this glyph, and you can basically from that page, you can highlight the alpha and just paste it right into your code. If we do hex of odd, so we get the code point using odd, and then we transform that to hex, we'll see that we get the string 0x3b1. The 3b1, the leading 0, of course, is irrelevant. Now, there's other ways to specify the character in a string. We can use escape codes, and we can use either the hex code or we can just use the actual name. Why do we want to be able to do that? Well, for example, you don't have the alpha character on your keyboard. You don't have, let's say, a smiley face emoji on your keyboard. So how would you type it in? Well, yes, you could copy paste it in the way we did with alpha, but there's got to be better ways of doing that. We're using our standard keyboard. So we can use the name, and to use the name, we use the \n escape code sequence. So it's always \n curly brace, and then inside those curly braces, the name. So that's why I was telling you the name was important. So that alpha, its name was Greek small letter alpha. So if we look at that string, if we type this in our code and then just print that string out, we will actually get the character alpha. And so we can use it anywhere in our string, right? Escape sequences can be used anywhere in a string. So if we write this, the letter \n Greek letter alpha is the first letter of the Greek alphabet. When we print that out, we'll get the letter and then the proper glyph, assuming, of course, that your font will, you have a font that supports displaying that particular character. We can also use the codes, and so we can use this \u, and this is a lowercase u followed by 4 digits. So the hex code with a \u must be 4 digits long exactly. And the capitalization of B doesn't matter. Lowercase b, uppercase B is the same. The only thing is it must be followed by 4 hex digits, right? So that's 0 through F. And so we could write it this way. The letter \u03b1 is the first letter of the Greek alphabet, and we get the same thing. Essentially, we've given the escape character code now for the letter alpha. So let's take a look at this Unicode character, which is the snake. So you can see that the code is 1F40D and the name is snake. So again, we can specify that character in Python by just using an escape sequence using the name. So it's a \n, the curly braces, and then the name of the character, which is snake. So if we do that, we'll actually see that in our editor. Again, assuming we have a font that can support that. Now note how the character 1F40D has 5 digits, right? The alpha that we saw really only used 3 digits, but we needed 4, so we padded with a 0 to the left-hand side. So it became that 4-character code. Here we have 5 digits. So we must use the capital U now, followed by exactly 8 digits. So to specify the character codes in escape sequences in Python, you use either a \lowercase u or a \uppercase u. The lowercase u must be followed by 4 digits. The uppercase u must be followed by 8 digits. So in this case, we have 5 digits. That's not going to work with the lowercase u. So we have to go to the uppercase u, which means we need exactly 8 digits, which means we're going to have to pad this. So even though the number here is given as 1F40D, we are going to need to specify it as 000-1F40D because this now gives us a total of 8 characters. And that's because Python needs to know if you allowed a variable number of digits after this \u, how would Python know that the character that comes after the D is part of your regular string or is part of your escape sequence? It doesn't know. So it needs to have this, basically this fixed size of characters that it's going to look at to figure out, okay, what goes into the code. In here for the \n, we had these curly braces as delimiters, so it didn't matter. But here we don't, so you need to basically have a fixed width. So if we type that, we will again get that snake. And again, just pad with zeros to make it to 8 digits. All right, so let's switch to some code and let's try this out. So this is a list of the various links that I used in the lecture. It's in the notebook, which is of course downloadable with your course materials. So let's start by looking at the odd function. We can get the Unicode code point of any character using the odd function. So for example, if we want to find the code point for A, we just have to pass in the single character A. And so we get 65 back, which, as we saw in the lecture, is the decimal code for the letter A. We can also look, for example, at, let's say, this alpha character. So I'm just going to copy paste it in here, because Jupyter Notebook does support these Unicode characters. So we can do that. And here we'll get that it's 945. We also have this snake, for example, emoji. And again, we can look at its character code. And that gives us this 128013. Now, all these are the Unicode code points in decimal for these various characters. So if we want to see the hex version, then we just need to specify hex. So we can say hex of odd of A. And the hex function is going to return a string containing the hexadecimal representation of that particular decimal number. In this case, the decimal number will be the code point, the decimal code point for A. And so we get 0x41. And the 0x prefix is really only there to tell us that, hey, this number here that I'm showing in the string is a hexadecimal number. And that's why we have the 0x. It's just a prefix used to indicate what's going on. So of course we can also look at the hex of, let's say, alpha. And so we get the same thing. We'll get the hexadecimal representation, which was that 3B1 that we saw. And then this one over here is going to have that larger code point. And so if we look at hex, we'll see that now we have 5 digits in that hex code. 1, 2, 3, 4, 5. 1F40D. Now, if you want to convert a hex number into a decimal, you can actually do that. So in other words, the reverse process using the int function. And the int function, well, we know that we can pass it, let's say, a 3.14, and it's going to give us just the integer portion of that. But int has another parameter that we can pass it, which is the base that we're interested in. So for example, we might do something like this, 3b1, and lowercase or uppercase b doesn't matter. And we'll have to specify, though, that this is in base 16. And so Python will be able to convert this 3b1 and return the decimal, the base 10 equivalent of that hex number here. Now, as long as your editor handles it, you can always paste in the glyph into a string, as we saw above. And in many cases, you can also use them as a variable name. So if I go back, let's say, to alpha, and I paste this in, I can say alpha equals, and then let's make it equal to the string alpha. This is actually perfectly legal. And now we can just view what is alpha, and of course it's just a label pointing to this string alpha. So we can use Unicode characters in our variable names. However, not every character will work. It has to be a letter or numeric-like character. And if you remember what I showed you in the lecture, there was the categorization of characters, and some of them were letter. But for example, the snake falls under a different category, which was the other symbol category. So we cannot use the snake, for example, as a valid variable name. So if we try and do this, let's say, we get, of course, this syntax error. It tells us it's an invalid character in the identifier. In general, you shouldn't be using these special Unicode characters as variable names because you're going to have a difficult time typing it in, and anyone else for that matter, because it doesn't show up as a character on your keyboard. So when you're creating variable names, stick to what's on your keyboard, basically. So we can also specify these characters not by pasting the glyph in. You may have an editor that doesn't support that, but you still want to handle special, Unicode characters that are beyond what's on your keyboard in your strings, for example. So in that case, we have to use escape sequences. And there's two types of escape sequences. One is by using the name of the character, and the other one is by using the code for the character. So let's look at the name first. So I'm going to say this. So I'm going to use the name escape. And so the name escape, we do a backslash, capital N, and then curly braces. And inside, we're going to type the name that is assigned to that particular letter. So in this case, I'm going to type in Latin capital letter A. That's the name of the symbol. And then I can just continue my string. So these escape characters do not have to stand on their own. They're just part of the string, and Python knows where it starts. It sees the backslash N, and where it ends. In this case, we have a delimiter around the name, so the curly braces. So Python knows to interpret this as a single character, and then the remaining ones are just regular characters I typed from my keyboard. They're still Unicode characters, but I could type them directly, just as if I had pasted that alpha or that snake glyph in here, right? It would be the same, just typing it in. But in this case, I can't type it, so I'm using the escape code. So always look on the bright side of life, let's say. So if we do that, you'll see that var is always look on the right. The capital A was basically converted into the glyph. So we have a font that can display the letter capital A, which is a good thing. Now we can also use the numeric code. Now in this case, we have less than 4 digits. The numeric code, remember, for A was 0x41. So it was 41. So there's less than 4 digits. So we can use a encoding using the code, and we have to use the lowercase u in this case because we have less than 4. We could actually use the capital U as well. I'll show you that in a second. So always look on the bright side of life. So if we do that, and we look at what that is, again, this escape sequence was converted back into the display character, into that glyph. Now, why 4? Well, remember here, I said that Python knows where the escape starts and stops. Here, with a lowercase u, a backslash u, Python knows where it starts. How does it know where it stops? Well, it stops after 4 characters, and that's why it needs exactly 4 digits in this code. Now, if you wanted to use the capital U, which remember expects 8 digits, you can certainly do that. You can use a capital U, but of course this isn't going to work because it's expecting 8 things and not 4. So it can't decode L. It says, well, I don't know what that is. So what we have to do here is pad with 1, 2, 3, 4 more zeros. And now we're back to where we were. So you can use the capital U always, but it needs to be 8 characters. The lowercase u needs to be 4 characters or 4 digits, right? But hexadecimal digits, so 0 through F. So if you have less than, if you have 4 or less digits, then you just use the lowercase u because you don't have to pad those 4 zeros in front. If you've got more than that, you're going to have to use the capital U. So let's take a look at the alpha. Alpha, remember we said was 3b1. So here we can just look at 3b1. Now, if we do 3b1, that's not going to work because we need 4 characters. So we need to do that, and we'll get alpha back. And if we want to do the snake, which was this one over here, then its character code was 1F40D. So again, I cannot use the lowercase because now I have 5 digits, right? I have 5 hexadecimal digits. So I need to use the capital U, which means I need to have exactly 8. So 1, 2, 3, that will bring us to 8 characters. And that converts into that particular glyph. Now we can take a look at another one. Let's say, for example, the grinning glyph. So what I'm going to do is actually bring up the website. So here's that website, and I'm going to look for those emojis. And in this one, I know that it's called grinning something. So I'm just going to search for grin. And you can see that we have different ones over here. So for example, let's take this one. And we can see that the character code for this one is 1F600, and the name is grinning face. So we can actually bring that into our Python strings using either the code or the name. Let's go take a look at that. Let's start with the name. So we'll go ahead and say \n and then the curly braces, and then the name of it is grinning face. So if we do that, as you can see, now we get our grinning face. So the character code for that one was 1F 600, if I remember correctly. So we're going to have to escape it. Now we cannot use the lowercase u because we have 5 characters here. We have 5 digits. So we have to use the uppercase, which means that we need to get this now to 8 digits. So I'm going to pad it with 3 zeros in the front. And we get the same thing. All right, thanks for watching, and I'll see you in the next video.